So I believe this is the second problem that was assigned on the uh, MyLab as an exercise problem. I believe this is very similar to this particular problem. Okay, so I'm not going to spend time to explain this again. I'll just leave you to work on this. So it looks like this is maximization problem. All right. So and instead I'm going to move on to this type of problem. We solved this once during our Friday class. So this is actually much easier to solve using the solver, because at least to me this is much easier because all the parameters and constraints are actually very structured. They provide it in a very structured way that there are less room to make a twist in the story, right? And it had to adhere to this type of structure. So what's the meaning of it? You have a source, you have destinations. It looks like you're shipping something from bank 1 to hospital 1 costs you $8. Shipping from 1 to hospital 2 costs you $9 and so forth. So this is, in other words, this is a transportation modeling type of problem. And what's special about this type of problem is the row total and column total becomes part of your constraints. It becomes part of your constraints. So as you can see that bank 1 can only supply up to 70. It has nothing to do with these numbers. I hope that makes sense to you. At some point, I hope that makes sense to you. Because if you think about the unit, this is provided as the parameter, right? So all these information inside of this particular block are the cost component, where the row and column total actually represents the units. Okay, those are the expected values in some way. So bank 1 can only supply 70, 280, 320. Again, it has nothing to do with this. Okay, it's just trying to utilize the matrix form of presenting information. And demand, hospital 1, we have a fixed demand of 100, 2 have fixed demand of 75, and so forth. So your challenge is going to be how to fill in. Okay, let me do it like this. So your challenge is going to be how to allocate those shipping quantities for each route to, I believe it's minimize your total cost. Okay, to how to allocate quantities in all these cells. Okay, some cells may be 0, some cells may have a very big value, but how do you allocate those shipping quantities on those routes, okay, in order to minimize the total cost? That's actually the nature of this problem. So eventually, these are going to be your decision variables. So we have actually more than 2 in this case, right? So even though it looks very scary, this is actually a very simple, very clear problem to solve. Okay, so what I'm going to do is I'm going to start a new spreadsheet to demonstrate the solution strategy using solver. All right, again, the 3 things. Okay, 3 things. The first one is all the available parameters. So since they're all provided in this format, I'm just going to leave it as is. Okay, and I'm going to copy this one more time. Okay, copy this one more time, and I'm going to empty this part out. Okay, I'm going to empty that part out. And so this is going to be our decision variables. So number 1, parameters are all clear. Number 2, we need to think about is the decision variables. And next move, we need to think about the objective functions. Objective function is the total transportation cost. Okay, how do you get total transportation cost in this case? So, well, you're thinking about doing this, right? Plus, and you keep doing it for all 12 cells, but there are easier way to do it. It's a sum product, all the cost components. You need to give them a one-by-one matching, one-to-one matching regions, which is going to be your quantity, which is also going to be your decision variables. Currently it's 0 because there's nothing in here, but we can, again, in a similar way, type some random numbers to see if our formula or function is working just fine. So this is our objective function. So in this type of problem, the constraints can be added a little differently. It's actually more convenient in this case. So I'm going to say total demand, okay, here, by doing this. So total demand, okay, or you can say total demand fulfilled from your solution. So if you think about what I'm doing here, you will see that solver will eventually give some numbers for all those 3 cells. Okay, all these values together will be the quantity that you're using to serve the demand for hospital number 1. So that's what I'm saying, total demand, or I can say total demand served. I should say served. All right, so this one is the target that we want to meet. This is actually the actual demand we have served through the final solution using the solver. Okay, so ideally these two should be the same, but now it's not because we're still looking for the we haven't started looking for the solutions, right? So I'm just gonna change it to general because this is not exactly money. All the same for these areas, and also here, total supplied. Okay, in the same way, think about what's the meaning of your row total here. Those are total quantities that that's shipped from bank 1 location. Okay, so again, none of those are money. So I'm just going to convert them into general number format. Okay, why I'm leaving one thing empty here, because that's your relationships. Okay, it will be all equal. Okay, the same thing goes here. All equal. Oops. They're going to be all equal. Okay, I think now we have set up this LP problem, and now we can run the solver. Or maybe before I move on, I can just highlight it to distinguish calculated cell with objective function and decision variables. Okay, here's objective function, constraints, here's decision variables. Okay, I'm gonna open solver. So objective is total transportation cost. We're minimizing it, and those are our decision variables, and our constraint is very simple. All the demands served should be equal to the demand you're expecting to serve. All the quantities supplied should be equal to your supplies. Okay, I suspect that this is going to cause some problem because of unit as a characters in those cells. But let me see if I can just do it as is. Yeah, I think this may have caused a problem here. I'm just gonna change it. Okay, let me run it again the setup is actually correct. So let me just read one more time. Okay, now we got the solution here. Okay, so we found a solution. See if it makes sense. So all the demand actually served for all the locations, and all the supply constraints are actually still intact. We didn't violate anything. This is going to be our transportation cost that's minimized. Okay, so this is the general steps you need to solve the transportation problem under linear programming. Okay, as long as you as long as you understand the meaning of this layout. Okay, what's the meaning of each cell and each row and column total, what you are exactly trying to achieve. So I would say that other things are pretty much the same with the first problem that we have solved. Okay, hope that it helped.